Good morning, gentlemen. This is Cadet Connor Ryan coming to you with the product demonstration of scenic rides. Um, I'm speaking on today on behalf of Cadet Brendan Old and Cadet Ian Njuguna because they could not make the recording. So let's just get right into it. Before I demonstrate my actual product, I want to demonstrate the changes from my previous product to now. We had to change and alter the implementation and how we were implementing it because we were moving it over to Kubernetes on Rancher. So Rancher and Kubernetes specifically has a built-in load balancing system. So in my previous project, in order to load balance my project, we used a Trafic container, which would automatically monitor this container right here, our scenic drives container, and monitor the health of it, monitor the usage of it as it ran, right? So whereas my first product here has 3 containers: the Trafic container, the scenic drives container, and the Mongo database. My new project, as you can see in this Docker Compose, obviously we did not use this Docker Compose YAML to move it onto Rancher. Apparently, it does not work that way. I found that out the hard way through multiple attempts. But here, as you can see, this is just the Mongo database and just the scenic drives container as we were moving on to Rancher. As I said previously, load balances itself, ex-naying the need for this Trafic container right here. So moving on, I wanted to point out real quick, as you can see in my documentation, I will have cited ChatGPT. We did use generative AI in order to create these adapted for Kubernetes YAML files. As I said here, we were using these YAML files. We ran into an error, so we separated them into a Mongo database YAML, Docker Compose YAML, and then a Scenic Drives Compose YAML. Because we thought that's what the error was, we just needed to separate these two containers. That was not the issue. In fact, the syntax for putting these onto Rancher is quite different. We tried to look for documentation. The documentation online wasn't really helping us out. So we utilized generative AI in order to transfer our previously made these, the original Docker Compose files were made by us using Docker Compose documentation. And then we just transferred them over, asked ChatGPT how to properly implement these into Rancher, and that's how we got these 2 YAML files right here. Moving on, I'm going to move into what my project looks like on Rancher, on the Rancher interface. Actually, first, real quick, I'm just going to show you the containers running in Docker. We have been having some trouble utilizing the database through Rancher. It may be due to some persistent storage errors, as was mentioned by Captain Schaefer earlier in the week. But here we have our 3 containers right here. They're running under the 394 group project. Right here, you see all 3 containers. So if that Mongo database is not working through the implementation on Rancher, always in our project folder, this YAML file right here, these YAML files right here will start up the web server, start up the Mongo database as it's supposed to be running, and the product can still run through that. Moving on, though, into Rancher. Here we have our ingresses. We try to make ingresses into our service. They didn't quite go as planned. I'll give you an example of how these ingresses look when they're clicked on. Couldn't exactly troubleshoot this. Didn't really have the time for it. That's another lesson in time management that I've learned throughout the course of this project. So as you can see here, we're getting a 503 error, service temporarily unavailable, as we try and implement these ingresses into our service. But here is our project right here as implemented on Rancher. As you can see, they fall under the same through this cluster service right here, this cluster IP service that we created. Our project in our pods fall under this IP address, the 10.43.117.210. So we have successfully created an orchestrator here to to take these ephemeral pods for our Scenic Drive's actual web application and our Mongo database, which serves as the backend for our web application. And we've taken them and placed them under one persistent IP address, and that's it right there under our cluster service. Moving on now, I would like to show you some of the security and monitoring implementations that we place on our web application. Obviously, Scenic Drives, as I've mentioned multiple times throughout the course of developing this web app, it will be hosting a lot of sensitive information that includes email addresses, passwords that people may be using for other accounts on different websites, different services. Apart from that, further versions of our web application, we wanted to implement a Google Maps API, so they would be tracking the user's location as they try and get from route to route. So all these location data, all this personal data is very imperative for privacy, and obviously we don't want this to leak. So as far as security implementation goes, we want to run our service through OWASP to find these potential attack points and patch them out of our system before we get users onto it. And that's what we'll be doing for security. Just very robust implementation of security there. And in the future, if we can, we tried for this project. However, we fell short utilizing the new View service to monitor security and monitor health at the same time. However, we were unable to implement it properly. It took a very long time, and it resulted in nothing. So if I could go back and change the amount of time that I spent trying to implement New View, I would, and spent more time developing our project further. However, for our health checks and our liveness checks, we have a pretty robust system here. Obviously, again, we're using Rancher, which comes with a built-in robust liveness checks and health checks. As you can see here, we have a readiness check that has an interval of every 10 seconds and a failure threshold of 3, right? So it can fail 3 of those before it shuts down the pod and reboots it, reruns another pod to try and remedy that error. Again, moving on to the liveness check, the program here will search for an HTTP request that will return a successful status code from our web application. Once that does that, it'll move on to the next 10-second interval later. As you can see here, we have a check interval of every 10 seconds. For our liveness checks, we have a failure threshold of 1. Through an AI session, Captain Schaefer explained to me the rule of the 3 nines, which is you want your web application to be running 99.9% of the time. And in order to do that, we need to only have a failure threshold of 1 so we can remedy that error before, as above, 30 seconds will pass before that error has any chance of being remedied. Here, it will attempt to remedy that error after the first 10 seconds. So very robust method of rebooting that pod if it does go down. And if there is an actual real error that can't just be solved by rebooting the pod, then that will take manual work to go in and fix. So again, that's the implementation in future versions to try and get a more automated security and automated liveness system. But this is how we will be checking that our system is running and working properly. Finally, moving on to the actual product itself, here is Scenic Drives. I know you gentlemen are familiar with this homepage. You've seen it a couple times. No real great progress on this front. We still have our 5 pages here. In further versions, obviously, we don't want to be able to add a drive while the user is not registered or logged in. So that will be a future implementation, as we don't want non-registered users adding drives that could potentially just be spam, trying to overload our servers, something like that, right? Here we have the featured drives. As of now, our web application can pass information onto the Mongo database, but we don't have an implementation here in our HTML and our JavaScript files to pull back from the Mongo database and provide the rides that are provided here. So I'll just show you some of the pages real quick. Right here we have our login page where we can choose our username, choose our password, and log on. As of now, while logging in takes the username and password. It simply functions as a create a user page, right? It just takes the username, takes the password, and passes it on to the Mongo database without any real checking to see if is already a user on that database and then logging you into that user's profile. So that's something we need to implement in the future. Registering a new user. Here we have, again, a very similar page, and as I said earlier, it does the exact same function, something we need to change in the future. One thing we are proud of, though, is if we try and create this account, there is some input validation as the text box is empty right now, and if we try to submit, it'll point to the first field that's unfilled out, and it will ask you to fill it out. Now, if we fill out the first one, it'll point to the second one as the first one has been filled out. So that's a pretty cool implementation. And then finally, we're going to go to our add a drive page. Here we can add a title. So we'll do the Shibuya Scramble from the fantastic movie, Fast and Furious Tokyo Drift, my personal favorite. Highly recommend it. The location obviously is in Tokyo, Japan. And then the description is a scenic, city drive. Our intention for the description here is to kind of satisfy that biker user case that we talked about earlier. Biker not necessarily representing a biker, but representing users of our application with various vehicle types. So in the description, we hopefully hope to implement more options where users can describe the drive in better detail so that users that are going to go to this location and take part in this drive, this scenic drive, will have a better idea of what kind of vehicle is best utilized for that drive, right? And then image file, here we can select the file and then submit the drive. The choose file has been implemented with some security measures as to prevent people from uploading harmful scripts. So it only accepts JPEGs and PNG files. And then submit drive, that will go to the Mongo database. However, there is no auto redirect after we do that back to the home page. So we have to go up and click back. And future versions, once we submit that drive, it'll pop up right over here under our featured drives right there. Still haven't implemented that. However, I am satisfied with how our product has turned out. It was a very difficult process, a very informative experience on how to use an orchestrator and how to use Rancher. A very useful application, useful service that we can use in the future to more easily implement security and monitoring protocols, as well as run and distribute these types of systems like my web app here, Scenic Drives, right? And overall, I've enjoyed the duration of this project. Our time management has been a little off, which explains the late video, as well as the multiple hour AI session. That's due to just having some of our partners out of commission over the course of the week on which the project was due. So a little more time management, better prediction of who's going to be where and when would have been useful for us in this case. However, I am satisfied with the product, and I hope you gentlemen enjoy Scenic Drives. Thank you. Have a great day.